We're now going to start combining exponents and radicals and everything we've learned about them. We'll follow these steps in order to complete examples 1 through 6. The first thing is to always simplify everything inside of the radical, also known as the radicand. So in example 1, we could simplify x to the 5th by first expanding it. So I've written it 5 times. I know that I can take out pairs. 1 dies, 1 escapes. This happens again, so we have 2 x's on the outside being multiplied and 1 left on the inside. We know that when we multiply the same base, we can add the exponents, and there's technically always an exponent of 1. So the outside would become x squared, and the x left by itself would stay on the inside. In example 2, we are going to go to D, subtract exponents of same base being divided. So I know that x to the 5th, take away 1, becomes x to the 4th. And I know that if I expand x to the 4th, I can circle my pairs, leaving nothing inside of the radical, but bringing out 2 x's. And again, x times x, like example 1, is x squared. You'll also notice with variables that when you're taking the square root, the simplified version will just be half of the square root. So half of x to the 4th would be x squared, and that's the shortcut. But when we have an odd exponent like 5, you're always going to have 1 left inside. And we'll see that a few more times. In example 3, there's 2 ways to solve this. We could first add the exponents on the top, or we could divide x and x right now because I know x divided by x is 1. I think that's a lot easier, so I'm going to do that. X to the 5th times 1 is still x to the 5th. And we already know from example 1 that x to the 5th is going to be x squared square root x. In example 4, we now have a numerical value in front of x to the 5th. I like to think about this by breaking them up. So I think of the square root of 16 times the square root of x to the 5th. They're the same thing. I know that the square root of 16 is a perfect square, so that's going to leave me with 4. And I know that x to the 5th is going to, again, be x squared root x. When we multiply all of this together, 4 times x squared is just 4x squared square root x. In example 5, I notice that we have a negative on the outside. I'm just going to put a 1 there so I remember, and of 0 in an exponent. I know that anything to the 0 value is just 1. So now we have negative 1 times x to the 5th. Again, we know that x to the 5th is x squared root x. So I'm going to multiply a negative 1 to the x squared on the outside, giving me negative x squared square root of x. In example 6, we have a few things going on. We have a numerator and a denominator. We have a fraction now. I know that I am not allowed to have a radical in my denominator. I know I need to get rid of that at some point, but I know I can simplify the numerator first. Again, like example 4, we know that the numerator is going to become 4x squared square root x. And then I'm going to bring down the square root of 3 in the denominator. To get rid of the square root of 3, we want to create a perfect square. So we multiply by root 3 because 3 times 3 will give us the square root of 9, which is a perfect square that can be simplified to 3. I'm also going to multiply the top by the square root of 3. We know that the square root of 3 can only be multiplied to x because they're both inside of square roots. 3 times x isn't going to become anything new, so I'm just going to put them next to each other. This still means that they're being multiplied, so we just put them next to each other, and the coefficient of this will just be 4x squared. And that is the most simplified form of this radical.